All right, so this video is going to focus on two different problems on how to find the compound interest here. So quick things first, so compound interest is generally talking about when you're borrowing money or investing money. So you have a set amount of money that you want to put into an account, or maybe you've gotten a loan out or something like that, for a certain amount of money at, let's say, a rate of 7% for the next 5 years, that type of thing. And you want to know how much money you're going to owe at the end of the 5 years, or if it's sitting in a bank, how much money have I earned over the years. That's what compound interest is generally talking about. Now, the formula for compound interest is over here on the right-hand side of your screen. And let's talk about what some of these letters mean here. So A represents the future value of that account. So that future value, how much you end up paying or how much you end up earning total in that account, is what the A represents. That's what you're trying to find. P is the principal amount. So that is how much did you borrow initially, how much money did you put into that account to begin with. You had $5,000, you stuck into account to earn interest, that $5,000 would be that principal. So the rate, so R, it represents the rate. An important thing to remember about the rate is it's typically always given to you as a percent. We can see here 6%, 6.5%. When you do plug it into the formula, you need to change that percent to a decimal, right? So write as a decimal. That is very important. Quick, in order to go from a percent to a decimal, you move the decimal place 2 times to the left. So 8% would really be the decimal. 0.08 is what you would use. T represents time in years, and that is important because with the problem, they don't always give you the time in years. You can see our first example has a time of 3 years. Our second example is 20 years. Okay, so I'm sorry, that doesn't help. But there's some examples that will give you, like 6 months or something like that. So then you have to understand, well, that's half of a year, so I'm going to be using half for my time, or 0.5, that kind of thing. The N represents how many times the interest is compounded per year. So number of times compounded. And they'll typically always tell you that in the formula. It's compounded 6 times a year. It's compounded, sometimes they'll give you the wording like semi-annually, which is twice a year. It'll tell you quarterly sometimes. That represents 4 times a year. So just pay very, very close attention to that. Which I just realized I didn't put the N. For example, A, that one is semi-annually, which will represent 2 times a year when we get ready to input this. You can do this formula and calculate it all by hand. It's a lot nicer if you do have a scientific calculator. Depending on what scientific calculator you have, there is a way to input this entire formula all in one line. I'm not going to go through that on this video. I am going to have a future video that is going to go through step-by-steps on how to work these problems, how to type them into a calculator, and how to get straight to the answer in one step. That'll be another video. So for right now, we will be using the calculator here. So let's start with example A. That one says that our principal is $2,000 at a 6% interest rate for 3 years, and it's compounded semi-annually, which means 2 times. So we are looking to find A in this formula. So our principal is $2,000. We're plugging in for P. Parentheses 1 plus our rate over N. So our rate is 6%, but as a decimal, that is 0.06. So 0.06 is going to go in your numerator, and N is 2 here since it's semi-annually. And that is going to be raised to the nth power. So N is 2. Time right here is 3 years. So that wraps up inputting that. So we need to clean up here. When it comes to cleaning up, do take this one step at a time. For my first simplification, I'm going to multiply that exponent over here. In our exponent, we have 2 times 3, which we know is a 6. Then I'm going to work on simplifying inside the parentheses. So we need to simplify everything going on inside there. So we would start with the division and then do the addition. So I'm going to drop the 2,000 down. And what I'm going to do is I'm going to take 0.06 and divide it by 2, which is this part here. And then we need to add 1 to it, right? So 0.06 divided by 2, then plus 1 gives us 1.03, and that was to the 6th power. At this point here, I'm going to rely on my calculator to do the rest of this for me. In my calculator, I'm going to type in 1.03, and I am going to raise that to the 6th power. And when we do that, I am getting 1.19405,229. That is a very, very big number. You don't want to round in these kind of examples if at all possible. So if you know how to do this in one line, that's going to work it even better. So after that, we need to multiply it times the 2,000 here in front, right? So when we do that, let's see what we get. I am getting 2,388 and 10459 as my decimal here when you type that into the calculator. Because this is talking about money, we want to round to 2 decimal places. So that's going to round down, giving us a value of $2,388.10. So what this means is, let's pretend this is an account that you deposited money. You put in $2,000. After those 3 years, it's earned that $388.10 of additional money that got added to it. So working on example B, we're going to do the same thing. We're going to plug and chug into this formula, starting with the principal, which is $30,000 for this one here. Inside the parentheses, 1 plus our R is 6.5%. As a decimal, that's going to equal 0.065 there. So that's going to be in our numerator. And that's going to be over N. So this one says daily here for N. Now there are 365 days in a year, but for some reason most books like to use the number 360 for daily. The problem will typically always tell you if it wants anything different. The books that I work with say to use 360 if it says daily. I'm not sure exactly why it does that, but it tells me to use 360, so I am going to use 360 for my N. So that means I'm going to raise it to the N times Tth power. So that means 360 times our time, which is 20 years. All right? So we need to simplify this. Always start by simplifying the exponent. So I'm going to rewrite everything else while I simplify that exponent. And that exponent is 360 times 20. So when we do 360 times 20, I'm getting 7,200. You're definitely going to need a calculator for this one. So simplifying the inside, this entire inside here, we're going to do the 0.065 divided by the 360, and then we want to add the 1 to it. Do the division first, then add the 1. Now, I'm going to keep this in my calculator. I have a calculator on my phone where I can do this in steps. Otherwise, if you don't have a calculator that's going to let you do that, write as many of the decimal points or the decimal numbers as possible. I am getting 1.00018056 as the inside of this parentheses. So I'll go ahead and I'll write that down here, hopefully you have a calculator that's going to let you take this and then raise it to the 72th power. Definitely learn how to use your calculator when it comes to this kind of math, especially if you're taking a class for a school maybe and you're in a financial math or like a contemporary math. They use a lot of big formulas like this, so having a calculator that you know how to use is really going to help you. And that was to the 7,200 power. Okay, so I'm going to do this all in one line, the rest of this problem here. So let's see, so that's 30,000. Let me make sure I have enough zeros on that. All right, so, and then we're going to multiply it by that decimal and raise it to that 7,200. Okay, so I'm almost there. 7,200. So when we do that, all right, this decimal raised to the 7,200 times the 30,000, I am getting $110,065.98. So you can see here they put in $30,000 into this account at a 6.5 interest rate, but it sat there for 20 years. It earned a lot of money, and it ended up with a value of $110,65.98. Otherwise, that's it for this video.